Welcome to section 5.5, day 1, CPCTC. So, what does it mean for two triangles to be congruent? It means that they are identical twins, which means that all of the angles are congruent and all of the sides are congruent. When I say all of the angles, I mean all of the corresponding angles. So, we can use our congruency statement to find corresponding parts. So A is the first letter, which matches up with D. So we know that angle A is congruent to angle D. Our second letter is B, and our second letter over here is E. So we know that angle B corresponds to angle E, which means they are congruent, since my triangles are congruent. And our third letter, angle C and angle F, these are corresponding angles. So we know that they are congruent since my triangles are congruent. And then we have corresponding sides. So let's look at the first two letters. We have segment AB and segment DE that are congruent to each other. So those are corresponding. Then we have segment BC and that's congruent to segment EF. So here's BC, here's EF. And then last but not least, we have the first and third letter. So segment AC is congruent to segment DF. And that's here's AC and here's DF. So here's our congruent statement saying that the triangles are congruent, and we know that all of the corresponding parts, corresponding means that they're in the same position, they're the parts that match up, are congruent. So what we know is that corresponding parts of congruent triangles are congruent. So let me say that again. Whoops. All right. So corresponding parts of congruent triangles are congruent. This is called CPCTC. So corresponding means that they're the letters that match up. They're the corresponding parts. And if I have congruent triangles, then we know that those parts are congruent. So corresponding parts of congruent triangles are congruent. So if two triangles are shown to be congruent, so we have a congruency statement, then all corresponding parts are congruent. So for example here, M is the midpoint of segment AB and segment CD. So the first thing we want to do is copy down our given. That's always the first step. Okay, so step number 1, this is given. All right, well, if M is the midpoint of segment AB, right, highlight segment AB. We know M is the middle, so we know that this half, AM, is congruent to this half, MB. So we can say that segment AM is congruent to segment MB, and we knew that by definition midpoint because midpoint cuts a segment in half. You just have to make sure that you're identifying the correct segment. So for example here, M is also the midpoint of segment CD. CD goes from C to D. So we know that this half is congruent to this half because M is the midpoint in the middle. So segment CM is congruent to segment MD, again, by the definition of midpoint. So you guys can see that your key word here is midpoint from your given, and that's why we have definition of midpoint here and definition of midpoint here. And now we have two pieces of information. We have two sides of one triangle congruent to two sides of a second triangle. So then our second step, we want to ask ourselves, do we have reflexive property or vertical angles here? And in this example, we have vertical angles that are directly across from each other. We can't name it angle M because there's actually 4 angles at M. So we need 3 letters to name vertical angles. So angle AMB Notice I got M in the middle there because M is the vertex of this angle, is congruent to, now we started with the red side and then ended with the green side, so we have to do the same thing in the right triangle. So angle BMC. So the reason we do that is to keep our corresponding parts in the same position. If you were to call it angle CMB instead, it would still technically be correct, but it is nice when we can keep corresponding parts in the same position. So we knew that those angles were congruent because vertical angles are congruent. And now we have enough information to prove that the two triangles are congruent, which is not our end goal. Our end goal is actually to prove that angle A is congruent to angle B, but before we do that, we have to prove that the two triangles are congruent. So now we have side, angle, side, and this is the included angle in between these two sides because it's the angle that the two sides make up. So by the SAS congruency postulate, we can say that triangle, and I'm just going to use the step above because we already matched up corresponding parts. Triangle AMB is congruent to triangle BMC. So that's why, even when we write vertical angles, that's why we want to keep corresponding parts matched up, because it will help us write our congruency statement as well. Now my last step is that I'm trying to prove that angle A is congruent to angle B. How do I know this? Because I just proved that the triangles were congruent. So I now know that these corresponding parts, A and B, are congruent. A and B are corresponding to each other. So since the triangles are congruent, I know all the angles are congruent, all the corresponding angles are congruent, and all the corresponding sides are congruent. So A and B are corresponding. So that means that they are congruent. So corresponding parts of congruent triangles are congruent. CPCTC. And you're like, well, do we need to mark that in our picture? You can, but we don't need to. We just marked what we needed to show to prove the triangles were congruent. And then as a byproduct, we now know that angle A is congruent to angle B. We're going to do two examples where we have overlapping triangles. So these look a little bit different. So first, if you see overlapping triangles, you want to separate them. And when you separate them, you do not want to change the orientation of them. So what I mean by that, actually, let's identify what is overlapping in these two triangles. What's the exact same in both of them? And that would be side GH. So when I separate these two triangles, we know that GH in this triangle is congruent to GH in this triangle because they're the exact same side. They were overlapping. So when you guys separate them, keep them in the same orientation. Don't rotate them, flip them. You don't want to draw them like that. Just keep them like this. Just pull them apart. And when you separate them, make sure that you write the letters at the points, right? So make sure you write the vertices. So label this J, G, and H, G, K, and H. So we already said that GH is congruent to GH because they were overlapping. So I'm going to write that down here. Anytime something is congruent to itself, we know that because of the reflexive property. Okay. So let me go back and mark our givens. We know that angle J is congruent to angle K. So I'm going to mark that in my picture. And then we also know that angle KGH is congruent to angle JHG. So KGH is congruent to angle JHG, and that's because it was a given. And now I have three pieces of information. So we had the two givens, which were angles, and then we had our overlapping side. So now we just have to figure out what congruency postulate this is. We have angle, angle, side. So how do I know if it's angle, side, angle, or angle, angle, side? you want to ask yourself, is this the side that connects the two angles? And no, it's not. So that's not the included side. So therefore we know that it's angle side, right? It's not the side in between the two angles. And that's how we can prove that triangle KGH is congruent to triangle JHG. So in this one, we don't have to use CPCTC because we were just trying to prove that the triangles are congruent, and we did that. Now, if we were trying to prove something else, we do know that the triangles are congruent. So now we know all the corresponding angles are congruent and all the corresponding sides are congruent. And one more example. So in this example, we had side GH that was overlapping. In this example, we have an angle that's overlapping. So take a second, see if you can find that angle. So angle C is going to be in both triangles. So angle C is overlapping. So I'm going to split the two triangles. Again, don't change the orientation. So we have triangle ABC, and then we have triangle ECD. And you can see that angle C in this triangle is the same. It's congruent to angle C in this triangle because they were overlapping. They're the exact same angle. So I'm going to write that step here. Angle C is congruent to angle C. Now, anytime something's congruent to itself, it is by the reflexive property, even though this is an angle. We've only really used the reflexive property for sides up until this point, but reflexive property still works for angles because reflexive property just means that something is congruent to itself. So it's like a reflection, right? Reflexive reflection. It's like you're looking in a mirror and you see the same thing back, whether it's a side or an angle. And then let's go back and mark our two givens. So we know that angle ABC is congruent to angle DEC. So ABC is congruent to DEC. So now we have two angles, and then they have another given that's a side. So we have side CB is congruent to side CE. So let's go mark that. Side CB is congruent to side CE. So now we have three pieces of information. So before we prove that these corresponding parts are congruent, we need to first prove that the triangles are congruent. So we have an angle, a side, and an angle. How do I know whether it's AAS or ASA? You want to ask yourselves, is this the included side that connects the two angles? And yes, it is. This side is between these two angles. So we know that it's angle, side, angle, congruency postulate. So now let's name the triangles. We want to keep corresponding parts in the correct position. So if we name the first one triangle ABC, A has no angle marks, B has 2 angle marks, and C has 1 angle mark. So if we said ABC, we have to go DEC. So again, no angle marks, 2 angle marks, 1 angle mark. So DEC. And we're not done because our last step is trying to prove that side AB is congruent to side DE. And those are corresponding parts. So AB is congruent to DE because corresponding parts of these congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. CPCTC. Also, you could have used this to prove statement to help you write your congruency statement because you know AB has to match up with DE. So that makes it pretty nice to write the congruency statement. And we don't have to mark it in our picture, but you do know that AB is congruent to DE. Right? And we also know that AC is congruent to DC because those are corresponding parts. And we also know that angle A is congruent to angle D because those are corresponding parts. So once we prove the triangles are congruent, we know that all of the corresponding parts are congruent. And that is all for 5.5.